Welcome to another Friday Night Restoration. Tonight I'll be taking a look at an Eico Model 324 signal generator. These are fairly common because they were quite popular back in, I'd guesstimate, the mid-50s and probably into the 60s. Service info on this is quite easy to find. You can just simply do a web search on Eico 324 and you'll find scans of this manual at numerous websites. For example, I went to the Boat Anchor Manual Archive and downloaded a copy. So I've got the schematic and parts list and so on. So briefly, it's a fairly simple design here. We've got two tubes, a 12AU7 and a 12AV7. And we start out here. Power supply uses a rectifier diode, filter cap. So here's our power for the set, and here is filament supply with a pilot light, and let's see, here's the output cathode follower with a coarse level adjust, and then there is a fine level adjust as well right here, and here's the actual RF oscillator. The band switch switches in various coils, and this also supports AM modulation, which is what this input is here. And then let's see, this is the AF oscillator, so you can either feed an external audio signal in, or it has a built-in audio frequency oscillator. I think it's at 400 Hertz, and this is the modulator tube. So, simple design, but it covers all the basic features you'd need in a signal generator like you would use for working with radios. Here's a look at the controls. We've got a nice big dial here where you dial in your frequency. Band select switch. There's the output level, fine, and the output level coarse. 3-position switch. Signal selection, we've got power off, external modulation or internal modulation, and here is the modulation output control, and here's the in-out. What that means is if in this last position you can either feed in a signal or you can actually get an audio signal out. If you want to test an amp or something, you could use this as an audio signal source. As far as the bands go, covers 150 kilocycles up to 37 megacycles directly, and then 37 to 435 using harmonics. I picked this up along with a bunch of other stuff a few weeks ago for free. I have not tried powering it up. I have not looked inside. All I know so far is that it does have a probe of sorts, which is kind of homemade. And it looks like he used the technique that I've used before when I haven't had much choice, which is taking a BNC connector and lopping off the center pin to make this old style connector. It does have the power cord. Looks to be in decent enough condition that I could try using it. The previous owner had a few cats, so I'll deal with some of this cat hair. So I think the first thing I'm going to do is grab some 409 spray cleaner, paper towels, and wipe it down, and then let's pop this open and see what's inside. Okay, that's a lot better. As you can see, it was fairly dirty. Now I've been taking the screws out. Just have one left here. And let's see. Like most Eico gear, it pulls out from the front, and all the controls and chassis and whatnot are mounted to the front panel. So there it is. I did a video a while back on an Eico 315, which I think is the predecessor to this. It uses octal tube and it's much larger, but inside fairly similar looking in terms of the copper plate chassis. Well, I guess that little dinky thing there is the power. No, that's not the power transformer. That's the power transformer. That little dinky thing must be part of the audio oscillator. So that's about as basic as you can get. So there's the band switch with the coils for the various ranges. Variable capacitor for tuning it in. There's the oscillator tube hanging upside down in close proximity to the coils and the cap. And then here's the other tube for the audio oscillator and Am modulator. There's a pilot light. It's a number 47. And down below we've got power transformer, rectifier. Looks like it's a selenium rectifier. And here's the filter electrolytic. And here are the various caps. So first thing I'm going to do is replace all these caps. Electrolytic and all the paper caps. I will also replace the selenium with a silicon diode. And then I'll start checking the resistors. I noticed one thing right away that's a big no-no, which is this capacitor right here. That's going off one side of the AC line and the other side is going to ground on the chassis. That's this guy right here. What is bad about that is that's a regular paper cap. If this was to fail, get leaky, short out, you've got full AC line on it. And because these are paper and wax, it can very easily catch on fire. What you should use is something like this, which is a safety cap. There's two types, X and Y. X, if it's going across the AC line, in other words, right from one side of the other, to the other rather, of the AC plug, and type Y if it's going from either side of the AC line to ground. There are also types like this, which are universal and you can use in either application. So I'm going to take this out and use this guy. The schematic shows two caps on the AC line. I've already found the one here, but it took me a while to track down the other one. It's actually all the way down here, so I also put a safety cap in there. I then proceeded to replace all the other paper caps. Now I'm checking the resistors, and they have drifted off pretty far in value, upwards of 50% too high. One puzzling thing though is in this area here, these values, these three resistors here, are not what is stated on the schematic. This is what I found in the generator. 10K, 1.8K to 20K. But if you look at the parts list, this should actually be 22K, this should be 1K, and this should be 100K. So I kind of just flipped a coin and decided to follow the schematic. So I've replaced one already and I'll replace the other two. If it doesn't work right, I may very well be going back to the values I found in the sets. I wrapped up with the resistors and I then moved on to rebuilding the power supply. There had been a filter capacitor in here. I removed that and took advantage of the screw down here and mounted a little terminal strip, and that's where I mounted my diode, two filter caps, and this resistor. Here's the old selenium rectifier. I'll just leave that sitting in there. You may have heard that if you replace a selenium rectifier with a silicon diode, you should add a dropping resistor in series. It's more critical in some circuits than others. In this case, I don't think it's that big of a deal, But I did increase this resistor a bit from 2.2K to 2.4K. Here's how that looks on the schematic. So it's a pi filter. It's a rectifier, one filter cap, resistor, another filter cap. And if I can make that out, I think that's supposed to be 140 volts. So we'll see what we get. If need be, I can increase that resistor a bit. And I think that is about it. Other than checking the tubes, which I will do next. And there are a few more resistors up top here. I suppose I'll grab my meter and check those. I think it's just two. And this thing that looks like it might be a resistor is actually a capacitor, as is this, and this down here. So we've got 12 AU7 GE branded, and this looks like the original Eico tube. Yep. Eico should be a 12 AV7. Rather similar tubes, I believe, but you can see the plate structure. It's a bit different. The 12 AV7, they're shorter. I wouldn't be surprised if this has better characteristics at higher frequencies. Oh, and we can see the date there, 3/56. So I'm assuming that either means the third week of 56 or March of 56. Here's the Knight 600B tube tester I restored a couple weeks ago. I've got it set up for the 12 AU7. I've already checked for shorts, and now for the value. One section is good, and as for the other section, also good. Excellent. Now I'll move on to the 12 AV7. Here's the 12 AV7, and one side is good, and the other side not quite as good, but still definitely in the good range. So I think we can proceed to try powering this generator up. Alright, I've reinstalled the tubes and I've hooked up my voltmeter to the main bus point here. And on closer inspection, I think that says 110 volts there and 125 over there. So I'm going to turn this on and let's see what we get. I'll plug it in first. Alright, I expect it to be a bit high now because solid state rectifier, so it'll conduct immediately, but then as the tubes warm up, the voltage should drop as it is. Excellent. Looks like it's stabilizing around 120 or so, which is a tad high, so I suppose I could increase that 2.4K resistor maybe to 2.7, but even so, that's what, within 10% or so. I think that should be fine. So now the question is, how do you know if it's actually working or not? Well, a few possibilities. If you have an oscilloscope, you could hook it up to the RF output. If you have a frequency counter, you could just try that. But I'm going to keep things real simple, and I'm simply going to use the radio that I restored last Friday. See, there's actually some logic, some thought I put behind the order I would do these projects in. So the first project was a tube tester, because I need to test tubes for all these coming up projects. And then I thought I would do a simple radio, knowing that I would be doing an RF generator next, and you can use a radio to test and calibrate an RF generator. Once a generator is calibrated, I can then reverse the roles and align the radio using the RF generator. So I've already got the radio turned on and warmed up. I've got it kind of in a null spot between stations. And let's see, I'll disconnect this stuff. Put the generator rather on its side, and I'll hook up the probe that came with it. I'm just going to lie it near the radio. and the radio should be able to pick it up. So let's see. I've got this on the B band, which covers 400 to 1200, in other words the lower part of the AM band. Got the output on high, crank the level all the way up, and I'll start tuning around. And there it is. Turn the radio up a bit more so we can hear that better. So that whistling is the RF generator. And as you rock the dial back and forth, you hear whistling, then a bit of a null, then more whistling. That spot in between the null point is when this frequency is dead on the receiving frequency on the radio. So yeah, that's excellent. Seems working all right. Now let's see, something else we can do is use the internal modulation. Right now there's no modulation, so you just get the carrier, so you hear the whistling as you go past it. But when you're locked on, you don't hear anything. If I turn on the internal AM modulation, we should hear a tone. And we do. It should vary with this. Control's dirty, not surprising because I haven't cleaned them yet. And it should also vary with this control. I might be overpowering the radio a bit because this is so close. I also don't have the shielding on, so the radio might very well be picking up the insides of this rather than this probe at all. Let's see if I remove this. Yeah, it makes no difference whatsoever, so it's actually receiving the signal radiating from the back of this generator. Okay, so I'm going to clean these controls and then put this back together, and then let's go through the calibration procedure. The first half of which says to do just as I've got set up here, to use an AM radio. I went ahead and cleaned the controls with some deoxit, but I can't put the cabinet back together because if I do that, I can't calibrate it, so I've still got it opened up here. Now the first thing we want to do is make sure that the dial is on 0 when the capacitor is fully meshed. In other words, when these plates are completely closed. So right now the plates are fully closed and the dial, it's pretty much dead on 0, so whoever had this before did a decent job of that. Reattach this knob here. And now the next step, that's better. This knob was scraping against the front of the cabinet before because it was pushed on too far. Much better. Alright, now the next thing I want to do is the individual band calibration, which will involve tuning these little slugs around these coils. Okay, now the first band, band A, 150 to 400 is below the broadcast band. But we can still use the AM radio by taking advantage of harmonics. So what we'll do is tune the radio to a known point, which is AM 670 in this case, and you tune this to 1/2 of that. 1/2 of 670 is 335. So let's get this right on 335.
By Lions is just $399.
And you can see it's off. The null on this is around 344. So let's put this on 335. And now I'll tune the slug on the back here. You can tell which slug is for which band because the slugs with the more turns of wire are for the lower frequency. So there's one on the far left, there's a lot of turns of wire. That's for the lowest frequency band. Oh, I'm using an alignment tool. Plastic tube with a metal shim in it. That's so your body doesn't affect the slug while you're turning it.
And do battle with it. It was a war between Lee and the microbacteria. He won, thank God. He was just singing a song.
Right, so right.
I was going to dance it, but I tell you,
right there.
Mr. Ramirez almost hit a ball one. Well, Bart is what they say.
Alright, got the null right on 335, right on the button. Go to either side to get the whistling.
There's the 1-0 to Ramirez. Slider started third
All right, do the B band. Now here we can go directly to 670,
He didn't send me that soccer ball. I know it's
and we should get a null. Well, this one's pretty far off too. It's more like 690. So put this on 620, 640, 660, 670 right there. And tweak this coil. Right about there. If I turn this Am Modulation on, there it is. Alright. Now for the upper bands, be nice to have a shortwave receiver for this. And then what they recommend doing is tuning in to the WWV stations. Those are the Bureau of Standard Broadcasts on these fixed frequencies, 2.5, 5, 10, 15, and so megahertz. I don't have, well, I do have shortwave receivers, but not one conveniently set up in my lab. So for that, I think I'll just use my scope. Plus I'm kind of curious to see what the output of this thing actually looks like. I'm expecting it will be something less than a pure sine wave. Just with this low of a part count. Plus they are relying on harmonics intentionally to do the higher bands. So if you had a pure sine wave, you wouldn't have the harmonics. Okay, as I suspected, there is a bit of distortion. Now let's check the frequency. How about that? 670.0. Topping it out a little bit because there's some noise in the waveform, but yeah, that's that on 670. Now let's see about doing the other band. So band C, get the dial right on 2, and frequency a little high. And as I was saying, you could just as well do this with a frequency counter too. That's good enough. And band D. Let's see. Should be 6. I'll tell you, this thing is not far off. The previous owner was a ham, and he had some nice gear, so I suspect he went through this whole procedure himself. Alright, you get the idea. You go through and do the rest of the bands. Something else to consider when you see a waveform that's all messy looking like this is that if you're using this to, say, align a radio, the radio is not going to see those harmonics and this noise. If you got the radio tuned to 6 megahertz and you're putting out 6 megahertz with some extra junk on top of it, the radio's front end is going to just be looking for 6 megahertz. It won't even see this other nonsense, so that's really not a problem. Now, as for the internal modulation, you just see a bit of noisy looking stuff when you're at the high frequency, but if you drop this down, then you can start seeing that there's actually a sine wave modulating that. I put the case back together, and I went over it a couple more times with the 409 cleaner. I think it's looking a lot better now. Here's one final fun little thing you can do with this generator. I've got it set for 600 kilohertz. I've got my AM radio set for 600 kilohertz. I've got the function set for external modulation, and I've got the external modulation jack hooked up to my WaveTech function generator. Now if I turn this on, I have got myself a little AM transmitter. Not much power to be sure, but it gets very distorted if I overdrive the AM modulation. But if I was to feed audio into this, I could have a little transmitter. Hope you guys enjoyed this look at an Eico Model 324 signal generator.